You know that feeling when you're using an app and it's so buggy, it just makes you want to throw your phone? And then there are other apps that are so brilliant, they just work? Well, the difference between those two experiences, it's usually not just about the code. It's really about coding versus the discipline of software engineering. So today, let's really dig into what that means.
To really get our heads around this, let's start with a simple analogy. What's the real difference between a doghouse and a skyscraper? I mean, you could probably knock that doghouse out in an afternoon with a few tools, right? But a skyscraper? Whoa, that is a massive undertaking. We're talking years of planning, a huge team of experts, and just an incredible amount of precision. And that right there, that's pretty much the exact same difference we see in the software world between a simple program and a full-blown software product. A program might be a quick script you write for yourself, something that just gets a job done. But a software product? Well, that's your skyscraper. It's complex, it's built for thousands, maybe millions of users, and it's designed to stand the test of time.
Okay, so if we're going to build one of these digital skyscrapers, we need to understand our building materials first. So let's break down what we actually mean by software and engineering, because believe me, it is so much more than just writing lines of code. First up, software. You know, we all tend to think it's just the code, the program itself, but it's actually the whole package. It's the executable code, yeah, for sure, but it's also all the libraries and other bits it needs to run, kind of like how a building needs its plumbing and electrical systems to actually be useful. And it includes the documentation, the user manuals, the instructions. Without all three, you've really only got a piece of the puzzle. And now for engineering. This is basically the exact opposite of just making it up as you go. It's all about having a disciplined, scientific approach. I mean, think about it. You would never want someone to just guess how to build a bridge, right? No way! You want them using proven principles, stuff we know works. The same is absolutely true for software. Engineering is the thing that makes the whole process predictable and the final product reliable.
And here, right here, is where it all comes together. When you take that systematic, disciplined engineering approach and you apply it to creating software, well, that's when you get something really powerful. That's when you get the blueprint for building those digital skyscrapers we've been talking about.
And don't just take my word for it. This is the official definition of software engineering from the IEEE. The words to really focus on here are systematic, disciplined, and quantifiable. It's all about turning the messy, often chaotic, creative act of making software into something you can actually manage, measure, and predict. The key takeaway is that it's a process.
And this diagram of the software lifecycle, man, this really drives that point home. Just look at all the steps involved here. The actual coding, that's just one little piece of this giant cycle. All this other critical work, figuring out requirements, designing the architecture, planning everything out, that's the blueprint phase. That's the engineering. And it happens way before a single line of code is written and continues long, long after. So why bother with all this? Why do we even need these blueprints in the first place? Well, because trying to build complex software without a real engineering approach, that can lead to some absolutely massive problems.
You need a blueprint when you're building a skyscraper, not a doghouse, right? So this is for large-scale software. You need it for scalability, so your digital building doesn't just collapse when more people start using it. It's about keeping costs under control, being able to adapt when things change, and of course, making sure the quality is there. Without this kind of discipline, projects can just fly off the rails, go way over budget, and end up a total mess.
All right, so we get why we need engineering. We know the problems it solves. But what does a well-engineered, high-quality piece of software actually look like? What are its defining features? Let's break down those characteristics.
First on the list are the operational qualities. This is the stuff that you as the user experience every single day. Does the app actually do what it's supposed to do? Does it do it without crashing? Is it easy to use? Is your data safe? Basically, does it just work correctly and reliably, day in and day out? That's the absolute foundation of a quality product. Next up, we have the transitional qualities. Now, this is all about how well the software can handle change. Can you move it to a new phone or a new server without it breaking? That's portability. Can it connect and play nice with other apps? That's interoperability. See, good engineering means the software isn't just built in a little bubble. It's designed to be flexible and to work with the world around it.
And finally, and this might be the most important part for long-term success, we have the maintenance characteristics. Is the software modular, meaning is it built from smaller, independent pieces that are easy to manage and update? that directly affects how easy it is to maintain. A well-engineered product is flexible and scalable, which means you can fix it, update it, and help it grow over time without the whole thing falling apart. You know, all this talk about maintenance and flexibility brings us to one last really crucial idea. A physical skyscraper, it eventually gets finished, the construction crew goes home. But a software product, it's never really done. It's designed from day one to be a constantly evolving structure. This concept is known as software evolution. The entire goal of software engineering is to build a foundation so solid that the software can be developed, maintained, and updated for years and years, constantly adapting to new user needs without crumbling under its own weight. So let me leave you with this final thought. The next time you open up your favorite app, whatever it is, try to look past the surface, past the buttons and the text. Because you're not just seeing lines of code, you're seeing an invisible blueprint. You're seeing the systematic, disciplined engineering that's holding that entire digital skyscraper together, making it work for you.